Okay, in this video, we're going to start doing calculations involving concentration of solution. So how much stuff you've got dissolved in a certain volume. Okay, so you've probably seen bottles around the lab with things like hydrochloric acid. It'll say 1m on it or 2m. That's a measure of concentration. We'll find out what that is. Okay, so first of all, we need to talk about the unit of volume, which is this rather strange unit of a decimeter cubed. And that's the same volume as a liter. The exam board don't like the unit, the liter. I think it's an SI unit. So we've stuck with this rather strange unit. But 1 decimeter cubed is a liter, and it's equal to 1,000 centimeters cubed. And usually when we're given volumes, they are given to us in centimeters cubed, so we need to be able to convert them into dm cubed. So 250 centimeters cubed, that's 0.25 of a dm cubed. Another one we often use, 25 centimeters cubed, comes up all the time. That's 0.025. So you divide by 1,000. Let's sort of try and remember that. The units of concentration are here. They are mole per decimeter cubed, and we abbreviate mole to MOL. Just lose the E. It's hardly worth it, but that's what it is. Okay, and that's the unit of concentration. Also, a lot more rarely, just much more rarely, sometimes concentration is measured, instead of moles per decimeter, it's actually measured in grams per decimeter cubed, and we'll talk about that a bit later, but mole per decimeter cubed usually. And this is the equation we're going to use. So concentration in moles per decimeter cubed is equal to the moles divided by the volume, and don't forget to convert the volume into dm cubed. And if you prefer it in the triangle form, there it is. Okay, so right, I'll just okay, so I'm going to copy that and use it later on. Okay, so let's do some practice calculations with those then. Okay, so right, 0.5 moles of NaOH are dissolved in a volume of 250 centimeters cubed. What's the concentration in moles per decimeter cubed? Well, the first thing we need to do is convert that volume into dm cubed, and that's equal to 0.25 dm cubed. We need to put our numbers into the equation, so we get concentration is equal to moles over volume. So that's equal to the moles is 0.5, the volume 0.25. That gives us 2 moles per decimeter cubed. That's the concentration of that solution. 2 moles per decimeter cubed sodium hydroxide is quite strong. You do use it in the lab. More often you'd use 1 mole per decimeter cubed, but it's not really concentrated. Okay, so let's do another question now. Okay, so what volume should 0.75 moles of sodium carbonate be dissolved in to make a solution of concentration of 0.5 moles per decimeter cubed? Well, we've got our equation here. We're going to have to rearrange it. So we want to get volume, don't we? So volume is equal to moles divided by concentration. Okay, the number of moles we've got is 0.75, and the concentration is 0.5. So that is equal to 1.5, I think, isn't it? Yep. 1.5. And the units are going to be dm cubed. So if you prefer centimeters cubed, that's 1,500 centimeters cubed. Just one more of these. Right, how many moles of HCl should be dissolved? How many moles of HCl? I'm going to find out the moles. Dissolved in 100 centimeters cubed. That's the volume. We need to convert that to dm cubed. So that's 0.1 dm cubed. to make a concentration of 2 moles per decimeter cubed. Right, so moles, rearrange our equation, which we've got up there. Moles is equal to concentration times volume. So put the numbers in. Concentration is 2. And volume is 0.1. So the number of moles is equal to 0.2 moles. Okay. Right, so there's some more examples of those at the end of the video for you to practice yourself with the answers, so you can. But let's move on to something a bit. Now we did mention earlier that usually we nearly always measure concentrations in moles per decimeter cubed. Occasionally, though, we measure them in grams per decimeter cubed. We've got to be able to interconvert the two. So what's the concentration of 0.75 mole per decimeter cubed HCl? Got to convert it into grams per decimeter cubed. Well, to explain it, I will say that in 1 dm cubed, we have 0.75 moles of HCl. So what we need to find out, how much does this weigh? What's the mass of that, okay? And the equation we're going to use for that is moles is equal to mass over mR. So rearrange that, we get mass is equal to moles times mR. So it's going to be 0.75 multiplied by the mR of HCl, that's 36.5. That is equal to 27.4, okay, grams. 27.4 grams. Now, this is in 1 dm cubed. So what's the concentration then? The concentration is simply 27.4 grams per dm cubed. So if you look at what we did there, we converted mole per decimeter cubed to grams per decimeter cubed. And what we did was we multiplied by the mR. Okay, we'll remember that for later. I'll just grab that. Okay, so now what we're going to do is the opposite. Okay, so here, what's the concentration of a 20 gram per decimeter cubed solution of NaOH in moles per decimeter cubed? So we'll do the same thing there. So we'll say let's say in 1 dm cubed, we have 20 grams of NaOH. How many moles is that? So how do we convert moles into, so we're going to use the equation moles equal to mass over mR. The mass we've got is 20, and the mR of sodium hydroxide is 40. So that's equal to 0.5 moles. And that's in 1 dm cubed. So what's the concentration then? The concentration is 0.5 mole per dm cubed. Well, let's see what we did there. All we did was we converted grams per decimeter cubed into moles per decimeter cubed, and we divided by the mR. Now we just compare that to what we did for the previous one, which is the reverse of that. There we go. We converted moles per decimeter cubed into grams per decimeter cubed. This time we multiplied by mR. So if you just remember those two little things, then you won't forget how to do it. It's not a very difficult thing to do at all, but because you're not asked to do it very often, people tend to forget, and very often, you know, in a test or something, or people will just do all the really hard things and they forget how to do that. It is quite easy, so remember how to do it. Right, now here's, just to finish off, here's some questions to do if you feel like you need some practice on all of that. So if I just make that bigger. Right, so there's 5 questions with the answers there for you to check. Okay, the first 3 are working out concentrations in moles per decimeter cubed, and these last 2 are converting between mole per decimeter cubed and gram per decimeter cubed. Okay, so we'll leave that there.